Okay, here's number 1 from the Unit 6 AP packet. So Kathy rides her bicycle along the straight road from home, starting at t equals 0 minutes and arriving at school at t equals 12 minutes. During the time interval 0 to 12, her velocity v of t is miles per minute. Miles per minute is the unit, which will be important. And is modeled by a piecewise linear function. So that means this graph is all linear segments. Find the acceleration of Kathy's bicycle at time t equals 7.5, indicate units of measure. Since this is v of t, finding the acceleration will be finding the slope, so v prime of 7.5. So finding the slope at 7.5. Since I'm fortunate enough that this is linear, 7.5 is right here. So if I want to find the slope of this segment, all I need is 2 endpoints. I need 7, 0.3 and 8, 0.2. And when I do my slope formula, I get negative 0.1. Okay, now make sure you go back and see it says indicate units of measurement. Well, since miles per minute is what velocity is, miles per minute squared is your acceleration. Using the correct units, explain the meaning of the integral of the absolute value of v of t dt in terms of Kathy's trip. Find the value. So immediately that should stick out to you, and you should immediately know this is total distance. So I will write my sentence. The integral 0 to 12 of the absolute value of v of t dt represents Kathy's trip, represents the total distance Kathy traveled in miles, since it says I have to use units, for the interval 0 minutes to 12 minutes. Now you can abbreviate that a little bit, but you do need to use endpoints at all times. Okay. Now, even though this is just 0 to 12, obviously, state it. Okay. It is a requirement to actually explain what those two limits also mean. So now it says find the value of the integral. Well, that just means find the area underneath velocity. So what I do is I find the area of each triangle piece by piece. I'll start with the first triangle. It's a base of 2 and a height of 0.2. So if I multiply them and divide by 2 for a triangle, I get 0.2. I get the same thing down here. What I will recognize is since it's absolute value, that has to remain a positive 0.2 because it's another distance she traveled. From here, I'm going to break this up into little pieces. So I can break this up into one triangle, and that's 1 times 0.3 divided by 2, so that's 0.15. Then I can break up this to just be 0.1. This is 5 times 0.2 divided by 2, so that's 0.5. Here I have a small triangle, 1 times 0.1 divided by 2, so 0.05. And this will be 1 times 0.2 divided by 2, which is 0.1. If I add all those pieces up together, 0.2 plus 0.2 plus 0.15 plus 0.1 plus 0.05 plus 0.5 plus 0.1, that gives me 1.8 miles. And I should be stating that this is the value of this integral that I'm looking for. Shortly after leaving home, Kathy realizes she left her calculus book at home, and then she returns to get it. At what time does she turn around to go back home? Well, the idea behind this is what time does she turn around? Okay, that's the key here. Well, the way we would know she would turn around is because velocity would change. It would change from being positive to negative. Okay, just the fact that it's negative is not good enough. That means she's walking home. It's an instant where the velocity changes from positive to negative. I can only see one instance of that, and that would be right here. Velocity changed from being in the positive values to the negative values. So at 2. So we want to write at t equals 2, Kathy turned around since v of t goes from positive to negative. The last thing is Lawrence also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by a different function. This is specifically for Lawrence, where w of t is in miles per minute from 0 to 12 minutes. Who lives closer, Kathy or Lawrence? Show the work that leads to your answer. Well, first thing is, I should probably figure out how far Kathy has to travel. So Kathy's displacement, that would be just the integral from 0 to 12 of v of t, because v of t was Kathy. Now that means before, where I had this positive 0.2, now it's a negative 0.2, because it's taking it's useless to me because it's part of the trip when she went back home. I just want purely displacement. So you can actually not have to start from 0. If you want, you can actually start from 4 or from 5 and just evaluate the time when she was walking home or riding her bike. In this case, you get 1.4 miles. Lawrence's displacement would equal this integral from 0 to 12 of pi over 15 times sine of pi over 12 t dt, and a calculator is great for this because it gives me 1.6. So we can clearly see Kathy's displacement is 1.4 miles, Lawrence's displacement is 1.6 miles. So Kathy lives closer because 1.4 is less than 1.6, or you can compare the integrals either way.